Good morning, students. Today we are going to discuss about transpose of a matrix. It's very easy to understand. Let us see the definition part. If A is a matrix of order m by n, then the matrix obtained by interchanging its rows and columns means we write the elements of a row, first row element in the first column, second row element in the second column, and so on. Then the resultant matrix is called a transpose of the given matrix and denoted by A dash or A superscript T. Normally we write A dash. So A dash is what? We are getting the elements of A dash will be what? A, J, I, and the order will be reversed. If it is m by n, it will become n by m. Like for an example, if we see a matrix A, here it is, first row element is what? 2, 5, minus 1. Second row element is what? 7, 4, 0. Then if you want to obtain A transpose, so what we get? First row elements like 2, 5, 7. So we'll write in the first column 2, 5, minus 1. And 7, 4, 0 we'll write in the second column 7, 4, 0. So the order here was 2 by 3 and the order of A transpose has become as 3 by 2. Now let us see some properties. For any two matrices, they have to be square matrices, that you have to keep it in mind, A and B. Mainly these four properties we'll discuss. Is the transpose of a transpose matrix is the matrix itself. Now if you have a matrix multiplied by a scalar and taking its transpose, so what we can do, we can take the scalar out and the result will be what? A transpose. And third is what? If it is A plus B or minus B transpose, so if you take two matrices, take their sum or difference and take the transpose, it will be equal to the transpose, the sum or difference of transpose of the matrices. Means A transpose plus for plus, minus for minus, and B transpose. Very important is what? Your fourth law. Fourth law is what? AB transpose. So you are having the matrix as product of two matrices. When you take its transpose, it will be equivalent to B transpose into A transpose, means in the reverse order. This is also called reversal law. So these all properties, we have the examples, questions given in the exercise. There you will verify with those examples and you will satisfy yourself about these properties. Now we will be discussing about symmetric matrix. What is a symmetric matrix? If you are having a matrix A Aij, it is said to be symmetric if A transpose is equal to A. It means Aij and Aji are same. Means A21, A12 is the same as A21. A13 is the same as A31 for all values of I and J. Just see the example. Here we have 3, minus 1, minus 1, 5. So in this, if you are taking the transpose, the first row will become first column and the second row will become second column. We get the same matrix. Here also just see, if it is what is the position? A12 and what is A21? Same. So they are same. So here in the second matrix also we find first row element and the first column element, second row element in the second column element, third row element and the third column element. They are the same. So we'll call these matrices as symmetric matrices. Now the next is what? SQ symmetric matrix. SQ symmetric matrix. So SQ symmetric matrix, what? A square matrix is called SQ symmetric if its transpose is equal to negative of it. That is, AJI is equal to minus AIJ. In particular, when I is equal to J, say for example, you are having 3 by 3 matrix, I is equal to J means A11, A22, A33. So what will happen? So AJI will replace J by I in both the sides. So we'll find AII is equal to minus AI. So take it on the right hand, this left hand side. So it becomes what? 2AII is equal to 0. It means AII is equal to 0. So what we observe in a SQ symmetric matrix, every diagonal element is a 0. Now take an example. See the SQ symmetric matrix. So here we find, first of all, we find that every diagonal element is 0 in the second matrix also. And we find, like say here, A12 is minus 5. So what is A21 minus of that? In the same way here, A12 here is H. What is A21 minus of that? A13 is what? G. What is A31 minus of that? It is minus sign, minus of that. In the same way, in the second, we find A23 is F. But what is A32 minus of F? And all the diagonal elements are what? 0. So this matrix, these two matrices will call as what? SQ symmetric matrix. Now, based on this, we have a theorem. Theorem is what? Theorem is first, every square matrix can be expressed as sum of a symmetric and a SQ symmetric matrix. Now see the proof. Let A be a square matrix of any order. Then we can write A as half A plus half A. Half is 1. And again, if we add plus A transpose minus A transpose, it becomes the same. So let us say that this matrix is P and this matrix is Q. We have assumed it. Now we want to check what is P and what is Q. So for checking whether it is a symmetric or SQ symmetric, we take transpose of it. So we are taking transpose of P. So transpose, now by the properties we'll find it's a scalar, it's a matrix, scalar out, transpose of it, and again by sum, so it is A transpose and transpose of the second matrix, and we know transpose of a transpose matrix is the matrix itself. So we find that it is half A plus A transpose. It is what? Nothing but your P. And again, let us see another one, Q. We are taking transpose both the sides. On the same way, it is half scalar out, transpose, then for the minus A transpose minus transpose of A transpose, and transpose of A transpose is A. So we are finding, and take minus out, so half A minus A transpose, it is nothing but your Q. Okay, so it is minus of Q. So what we observe, that P is a symmetric and Q is a SQ symmetric matrix. Now, so we can say A is sum of a symmetric matrix P and a SQ symmetric matrix Q. Let us have one example. Example is what? If A and B are square matrices of same order, then prove that AB transpose minus BA transpose is a SQ symmetric matrix. So if you want to check any matrix whether it is a symmetric or SQ symmetric, we'll take its transpose. Let P is equal to the given matrix. Now we are taking the transpose both the sides. So again we'll apply the transpose of two matrices, transpose of this and transpose of the second. Again here this particular matrix is the product of two, to reversal law. So B transpose transpose A transpose, that is A transpose transpose B transpose. Transpose of transpose is B. Here also it is A. So we are finding, take minus sign out. So we find it is minus of P. So we can say that AB transpose minus BA transpose is a SQ symmetric matrix. Now based on this we have the questions in exercise 3.3. You start doing the questions of exercise 3.3 and then come back to me. I am available for clarifying your any doubt. Thank you. Do the practice, interact and have a great day. Thank you very much.